All right, guys, today we're going to talk about something that doesn't seem science at all. There's a lot of math that goes into it, but it's a really nice way that you can take a simple mathematic concept and apply it to science. So, we're going to talk about something called an equation. Okay? So, in math class, we talk about equations, and if you notice, it has this at the front of it, which is talking about like equaling something, right? And so we know it's math. If I were to give you a worksheet that said, 7 times 10 equals, of course you would say, okay, 7, 10 times, do the math in your head, maybe count some fingers or toes, and you'd say 70, right? We have the beginning part, we have an equal sign, and then we have the end part. We have an equation, and we have a solution, right? And we're going to use the same concept, the same format. It's just going to look a little bit different, okay? So in science, we've been talking about chemical compounds. We've been talking about chemical equations and chemical reactions, right? Not really chemical equations. That's what we're going into now. But for example, we've talked about ionic bonds, and we've said if we have a metal and a nonmetal that combine together, some examples we used were sodium and chlorine, right? And we said, okay, so sodium and chlorine come together and we get sodium chloride. This is an ionic bond. And then we talked about some covalent bonds, right? Where we had something like hydrogen and chlorine, right? Hydrochloric acid. These are two nonmetals. This is a metal and a nonmetal. Ionic bonds work differently than covalent bonds. Ionic bonds are the gaining or the losing of electrons, whereas covalent is the sharing, right? So hydrogen needs one, chlorine needs one, and they say, hey, let's just share one with one another, right? And so they end up doing that. Ionic bonds, they don't do that. Sodium needs to get rid of one and chlorine needs to gain one. So sodium gets rid of one and chlorine takes it, right? It's the gaining or the losing of electrons versus the sharing. So we're going to go ahead and take this into the next step, which is basically saying, okay, sodium and chlorine come together. We're going to represent that. We're going to show how this actually happens. Or let's take something like this, simply because we're dealing with subscript, and that'll help to explain some of this, and say, how do we get water? Okay, like we can actually do this in class. It's an easy thing to do, but we can make our own water, and it's a pretty cool process. But here's what it looks like, okay? We represent this with an equation. We say hydrogen plus oxygen equals or yields H2O. Okay? Hydrogen plus oxygen. Now, if we're being technical, which we will be for doing this, we'll say, well, hydrogen and oxygen are both gases, and remember that gases, they don't ever go alone. They're always diatomic molecules. So that hydrogen is actually an H2, and that oxygen is actually an O2, which means that we have a hydrogen bonded to another hydrogen. So there's two hydrogens. And the oxygen, being bigger, is bonded to another oxygen, right? So we have two hydrogens, two oxygens giving us H2O. And that 2 belongs to the H, so it's telling us there's two hydrogens, okay? Is this correct? Yes, it's absolutely correct. However, we have two hydrogens, we have two oxygens, and here we have two hydrogens and one oxygen, okay? And so, although it's correct, and this is what happens, anybody who's thinking mathematically would say, yeah, but we only have one oxygen. What happened to the other oxygen, okay? And that's what we're going to be dealing with here, because this is what happens, and that this other oxygen, it doesn't just disappear, okay? It can't happen. It has to be accounted for, and that's what we're going to be working on here, okay? So we have this left side called reactants. These are the things that are physically reacting together. Okay, reactants. This means to yield or to give us something new. It's kind of like the equals, okay? And then we have this, which is our product. Our product is what we are left with, okay? Reactants, yield, our product. And although this is good for representing what's happening, we have to balance this equation. And I know that means nothing to you, but that's what we're going to be working on here, okay? And so that's just the explanation of it real quickly. Now we've got some rules to go through, and that's not a lot of fun, but it is really important, okay? So let's just explain a few of these things, and it will help set us up. In the next video, I'll actually go through some of the equations that we have on our worksheet, okay? First of all, it says subscript. We've talked about this enough that we should know what it is. A number that goes on the bottom of an atom that tells us the atoms are bonded together. You cannot change the subscript in balancing a chemical equation, which is true. You can't just change it and say, ooh, never mind, we only want one oxygen because it's H2O, so we'll just make that 1O. That's not how it works, okay? But the example they give us is like O2, and this is our subscript. It's the 2 here, which again tells us instead of just being one oxygen atom, it's actually 2 of them bonded together like that, okay? So that's subscript. The next is coefficient. When we start balancing these, we're going to have to go back to this. This doesn't work, right? We already said mathematically it doesn't work. Scientifically, it does. We understand that hydrogen and oxygen gives us H2O. Awesome. But mathematically, it doesn't work, right? And so science is concerned with the math. That's how we use it to prove science. And so we have to make sure that this is all making sense. And what we're going to have to do is we're going to have to balance these equations. And this involves putting a number in front of these. So, for example, if I said 2 oxygens, like that, it means that literally I have 2 oxygen molecules, okay? So it'd be like this. This is 2 oxygens, or 2 hydrogens. Give me 2 hydrogen molecules, like that. So this coefficient is telling me how many of that molecule, versus the subscript is telling me that these are bonded together, right? So it'd be 2 H's bonded together. So the coefficient is the number in front of it, as we see here, 2 H2O. Parentheses. Sometimes in chemical equations, we will see parentheses, okay? This will happen. You'll see this, I think, only twice, maybe 3 times in the worksheet I'm going to give you here in a minute. But the same rules for using parentheses in math. Anything outside of the parentheses is applied to everything inside of them. So 2 H2Os, as we see here in this example, is literally telling us, all right, we have an H2O. This is one molecule, and since this is on the outside, it's multiplying by it, so we actually have 2 H2O molecules. Okay, so now I have 2 H2O molecules. If it was just H2O, that would be represented there, and that would be correct, right? But it's not. It's 2 H2O. That's how our parentheses come in. And then we're going to be moving on to balancing equations, making sure that it all makes sense. And we have to do this because of this very, very important concept called the law of conservation of mass, sometimes called the law of conservation of energy, which says nothing is created, nothing is destroyed. The same amount of mass always exists. And if it appears that something doesn't exist or it was destroyed, it actually just moves somewhere else, okay? And so back to this, right? We can't just say hydrogen, oxygen gives us H2O because mathematically it doesn't make sense. Something happened to one of those oxygens, and we have to account for it, okay? And so that's what the conservation of mass dictates. It says we have to do that. And so we're going to do that, okay? This is the concept that is basically leading this. And here's the steps for balancing equations. 4 of them. I'm going to take you through them. It seems like, oh gosh, 4 steps for each one. But honestly, it's pretty quick. It's pretty easy. We'll check the valence to make sure the compounds are correct and fix any diatomic gases necessary. I'll have all of them correct on the worksheet, so we really don't technically have to do that. But that is an easy mistake to make, just putting a gas there without having it as a diatomic molecule. We'll count all the atoms of the reactants and products. Okay, so we'll determine how many there are, which is like what we did here with our H2O. We counted all the atoms and made sure that it was balanced or not balanced. Then we'll pick an element that is not equal. So here we said H2O, it's not equal. Okay, technically here, I mean, I know I've started to balance already. I added some coefficients. I made 2 H2s. Here we have 1, 2, 3, 4 hydrogens. Over here, remember this is supposed to be like a math equation, I only have 2 of them. And here I have 4 oxygens, but I only have 1 there. So we're trying to make them equal, right? And we do that by adding coefficients. If I took away this, take away one of those, and I would have 2 oxygens, okay? So keep that in mind with multiplying them. So pick an element not equal and add a coefficient as needed. Sometimes you might have to add a couple of them. And continue adjusting coefficients until it all balances. Same number of atoms on each side of the equation, reactants and products. One thing to note, if a compound starts with H, it's probably an acid. We talked about HCl as hydrochloric acid. Okay? So I'll leave it there. This should be a quick run through of all the basics. And the next video, I'm going to actually go through and show you the worksheet.